Lake Michigan, a vast inland sea of fresh water. Its surface shimmers, reflecting the sky. It is a world we think we know so well. We see its moods change with the seasons, from tranquil summer blues to the gray, churning fury of a winter storm. We build our cities along its shores, we sail its waters, we draw life from its depths. But beneath that shimmering surface, there is another world. A world of immense pressure and perpetual twilight. A world that holds secrets we are only just beginning to comprehend. Down in the cold, silent darkness, the lake bed stretches out like a hidden landscape. It is a place of subtle contours, of ancient sediments laid down over millennia. And so it was, on a seemingly ordinary day of scientific survey, that this familiar body of water revealed something truly extraordinary. A series of perfectly formed, almost manufactured-looking depressions in the lake floor. The lake, it seems, had been guarding a remarkable secret. A mystery that draws us deeper into its cold, dark, and utterly captivating heart. It began not with a dramatic splash, but with the quiet hum of machinery aboard a research vessel. It was the summer of 2024. A team from the Great Lakes Research Institute was conducting a routine bathymetric survey. Their mission was simple: to map the lake bed with ever greater precision. The vessel moved slowly, methodically, back and forth in a grid pattern. Below the hull, a multi-beam echo sounder sent out fans of sound waves, listening for their return. For days the work was predictable. Then, something unusual appeared on the monitors. It was an anomaly. A series of distinct circular pits. They looked entirely out of place, like someone had taken a giant cookie cutter to the soft sediment of the lake bed. The initial reaction was one of disbelief, then intense curiosity. They went back over the area, scanning it again and again. The features were real. There, in the silent darkness hundreds of feet below, was a field of mysterious holes. Each one was remarkably uniform, almost perfectly circular, measuring around 30 feet in diameter and plunging down another 10 to 15 feet into the lake bed. They were arranged in peculiar lines, almost like footprints left by some unimaginable giant. The discovery demanded a closer look. So, the research team returned, this time with a more focused mission: to map this strange phenomenon in its entirety. They concentrated on a 50-square-mile patch of the Mid-Lake Plateau, about 40 miles offshore from Ludington, Michigan, in waters reaching depths of over 400 feet. Using advanced high-resolution multi-beam sonar, the scientists painstakingly charted the area. The picture that emerged was astonishing. It was not just a handful of holes, there were hundreds of them. They were arranged in long, linear chains. Some chains stretched for several miles across the lake bed. The patterns were not random. They seemed to follow specific paths, almost as if something had methodically moved across the landscape. The sheer scale and organization were unlike anything previously documented in the Great Lakes. The precision of the holes was perhaps the most baffling aspect. Each depression was sharply defined, with steep sides and a flat bottom. They were not the gentle, eroded hollows one might expect from natural water currents. They looked freshly made, a stark contrast to the soft, silty sediment surrounding them. This comprehensive map became the foundational piece of evidence. It was a silent, beautiful, and deeply perplexing chart of an unknown world. With the map of the strange holes laid out before them, scientists began the difficult task of explaining their origin. The first and most obvious place to look for answers was geology. The Great Lakes are the product of immense geological forces, the slow, grinding power of glaciers, perhaps related to groundwater seeping up from below, water trapped in deep sediments beneath the lake bed, gas trapped in deep sediments beneath the lake bed. As fluids push through soft silt and clay, they can fluidize the sediment, causing collapse and a circular depression. This happens in oceans worldwide, but Lake Michigan's holes present a problem for that idea. Pockmarks are usually randomly distributed. These holes are highly linear, chain-like. Another idea: post-glacial history and isostatic rebound. Massive ice sheets retreated, the land slowly rebounded as weight was removed. That slow crustal movement could create stresses and fractures deep in the bedrock. Fractures might act as conduits for fluid or gas release, creating holes in the overlying sediment. Yet this idea has issues. The features look remarkably fresh and sharply defined. Geological features usually show age and gradual formation. These holes appear relatively recent. While geology remains a leading contender, perfect circularity, the sharp edges, the long track-like patterns, don't fit any single known geological model. When geology fails to provide a complete answer, the next place to look is biology. Could these strange uniform pits be the work of living creatures? The natural world is filled with examples of ecosystem engineers. The primary candidate for such a feat would have to be a species of fish. Some fish are known to create nests, or redds, by excavating depressions in riverbeds or lake beds during their spawning season. The lake sturgeon, a prehistoric giant that has prowled the Great Lakes for millions of years, is known to clear areas on the bottom. However, the scale of the Lake Michigan holes is simply immense. A sturgeon redd is typically a few feet across. These pits are 30 feet in diameter. Another biological theory ventures into the microscopic. Could the holes be related to massive colonies of bacteria or other microorganisms? In some marine environments, microbial mats can influence the chemistry of the sediment, causing gas to build up and release, creating pockmark-like features. If specific nutrients are being released along subsurface fractures, they could support linear colonies of microbes. Yet, like the geological theories, the biological hypothesis struggles with the evidence. The sheer regularity and manufactured appearance of the holes still feel unnatural. Biological processes, even on a grand scale, tend to have a degree of organic messiness to them. Furthermore, if a large animal were responsible, one might expect to find other signs of its presence: tracks, burrows, or remains. For now, the idea of a hidden lake creature remains a compelling but unproven flight of fancy. If neither geology nor biology can fully account for these mysterious formations, we must turn our gaze toward ourselves. Could these holes be the result of human activity? The Great Lakes are not pristine wildernesses. They are working waterways and industrial centers. The lake bed bears the scars of our presence: shipwrecks, pipelines, forgotten dumping grounds. The linear patterns in particular strongly suggest something methodical, something that might follow a path laid out by a vessel or a piece of equipment. One of the first theories to be considered was that the holes were old anchor drag marks. A large ship dropping and dragging a heavy anchor could certainly carve a trench in the lake bed. However, this theory quickly falters. The features are not continuous trenches, they are a series of distinct, separate pits. Another possibility relates to historical industrial activities. In the past, the lakes were used for practices that are now banned. Could the holes be the result of some forgotten method of resource extraction, perhaps a form of underwater demolition or disposal from a bygone era? Perhaps they are craters from the disposal of munitions decades ago. Finally, there is the unsettling possibility of a clandestine or undocumented activity. Could someone be doing something in the deep, unmonitored waters of the lake? Perhaps it is a new, secret technique for underwater surveying or resource prospecting. The human cause theory is compelling because it accounts for the regularity and precision. But until a specific activity can be identified, it remains just one more piece of the grand puzzle. The discovery of the holes has sent waves of excitement and debate through the community of scientists who dedicate their lives to studying the Great Lakes. Dr. Evelyn Reed, the lead scientist on the initial survey mission, expressed the team's astonishment. "In all my years mapping the lake bed, I have never seen anything like this. The data came through and we all just stared at the screen. They are so perfectly formed, so orderly, it felt like finding crop circles on the bottom of the lake." Geologists like Dr. Samuel Carter from the University of Wisconsin approach the puzzle with cautious skepticism. He points out that extraordinary claims require extraordinary evidence. While he finds the features fascinating, he leans toward a geological explanation. "My gut tells me this is a fluid escape feature. Perhaps it's the unique combination of our specific sediment type, the underlying bedrock structure, and the pressure at that depth." From the biological perspective, experts like Dr. Anya Sharma are intrigued but doubtful about a living culprit. The idea of a giant hole-digging Lake Michigan monster is wonderful for the public imagination, but it's not very likely. The energy expenditure to create one of these pits, let alone hundreds, would be colossal. No known freshwater species has a life history that would support such behavior. These expert opinions highlight the central challenge of the discovery. It defies easy categorization. This interdisciplinary confusion is a hallmark of a truly great scientific mystery. It forces researchers out of their silos and encourages collaboration. As Dr. Reed summarized, "Right now, every theory is on the table. We have to be detectives." Solving this underwater enigma requires more than just theories. It requires a journey to the site itself. But visiting a place 400 feet beneath the surface of Lake Michigan is no simple task. The environment is one of total darkness, near freezing temperatures, and immense pressure. The primary tool for this next step is the Remotely Operated Vehicle, or ROV. An ROV is essentially an underwater robot, tethered to the research vessel by a long umbilical cord that supplies power and transmits data. Piloted by a technician on the ship who watches a video feed from the robot's cameras, an ROV can be navigated with incredible precision. It can hover over a hole, descend into it, and examine its walls in minute detail. Equipped with powerful lights, high-definition cameras, and manipulator arms, it can become the eyes and hands of the scientists above. In addition to ROVs, scientists may also deploy autonomous underwater vehicles, or AUVs. These untethered, torpedo-shaped robots can be programmed to follow a preset path, collecting data over a much wider area than a tethered ROV. These robotic explorers are the key to unlocking the secrets of the deep. Beyond the sheer thrill of a good mystery, the discovery of these holes has profound implications for our understanding of the Great Lakes. These vast bodies of water are not static pools. They are dynamic and complex ecosystems. If the holes are caused by groundwater upwelling, it could mean that there is a significant and unmapped connection between the lake and the aquifers deep underground. This could have major consequences for water quality and chemistry. Such vents could be introducing water with a different chemical makeup, richer or poorer in certain minerals and nutrients, into the deep lake environment. This, in turn, could create unique microhabitats on the lake floor. Scientists are eager to see if these holes are hotspots for life. It is possible that chemosynthetic bacteria, which derive energy from chemical reactions rather than sunlight, could be thriving in these locations. This could form the base of a unique food web, attracting other, larger organisms to these deep lake oases. The discovery also has potential real-world impacts on the communities that depend on Lake Michigan. The lake supports a multi-billion-dollar fishing industry and a vibrant tourism economy. For example, if these features prove to be important spawning grounds for a key fish species, their protection would become a conservation priority. Conversely, if they are signs of geological instability or gas release, they might need to be considered in the planning of any future underwater infrastructure, such as pipelines or communication cables. Ultimately, the holes are a powerful reminder of how much we still have to learn. They represent a new frontier in Great Lakes science. The holes matter not just for what they are, but for the questions they compel us to ask and the exploration they inspire. The research vessel has returned to port. The data has been archived. The first wave of scientific papers are being written. But on the floor of Lake Michigan, in the cold and silent dark, the holes remain. They sit there, a vast and enigmatic pattern waiting patiently for our next visit. The mystery is far from solved. In many ways, it has only just begun. Each theory, geology, biology, human intervention, carries its own tantalizing possibilities and its own frustrating inconsistencies. The truth remains tantalizingly out of reach, hidden beneath 400 feet of water. What will the next expedition find when it sends its robotic eyes down into the depths? Will the cameras reveal the telltale shimmer of escaping gas? Will they find strange markings on the walls? Will they catch a glimpse of an unknown creature retreating from the lights? The possibilities are as deep and as wide as the lake itself. This discovery has reawakened our sense of wonder for a place many thought familiar. It reminds us that even in the 21st century there are still blank spots on our maps. We look out over the vast, shimmering surface of Lake Michigan with new eyes. We know that beneath that placid facade lies a landscape of incredible and unexplained features. The story is not over. The lake is waiting.